Okay, so let's start talking about some of the design principles. The way we're going to do this is we're going to go through those solid guidelines, explain why each guideline came about, like why is it justified, what problem does it solve, and then what are some design patterns that work in the service of fulfilling the guideline or solving the problem. And the first one, SRP, just says a class should only do one thing. Think of it as a version of SOFA, but for classes. If you can't describe what the class does in 25 words or less, it's probably trying to do too much. And the reason for this is that anytime a class does more than one thing, it has more than one reason to change. And the goal here is to isolate things that change from things that stay the same. So each different responsibility that a class has is a possible axis of change. It's a thing where if you make some change to that functionality, you've got to change the class, even if its other responsibilities aren't affected. So part of good object-oriented design is to try to put your responsibilities in places so that any given class really only has one small set of things that could cause it to change. One warning tip-off just qualitatively is if you have a model that is accumulating many different sets of behaviors. And in a lot of applications that you would write in a course like this, the model for your user is a classic place where this starts to happen. So for example, even in our simple rotten potatoes example, we've kind of overloaded the concept of a user because there's a moviegoer, but there's also an authentication principle, and they might also be a member of a social network if your app has social networking stuff built in. So each one of those additional things that is accumulated into the user class is one more reason for that class to change, even when the other stuff stays the same. So if you have a really big class file, that's a tip-off that you might be violating SRP. But as you might expect, there's also a quantitative way to measure it. And one of the ones that's pretty popular for measuring responsibilities is Elcom, or lack of cohesion of methods. And the intuition is pretty simple. If you have a certain set of instance methods, and you have a certain set of instance variables or attributes, what you would expect in a class that has one responsibility is that most methods touch most attributes, right? Because if you have these methods over here only touch these attributes, and these methods over here only touch these other attributes, really what you're saying is this is actually two little classes that ended up getting put under a single umbrella. So you can compute this by just saying how many of each do you have. Just take the sum over the product of the methods and the variables. There's another variant called Elcom 4, which tries to measure a similar thing but does it with a quite different technique. You basically make a graph in which methods that are related to each other by accessing the same instance variable are connected, and then you look at how many different connected components there are in the graph. And in either case, a high value for lack of cohesion suggests a possible SRP violation. So as with individual methods, there's both qualitative and quantitative things that you can look at. One thread that was, when Rails came out and Active Record provides all this great functionality, there was a thread in discussion groups about whether Active Record-based models violate the single responsibility principle, because on the one hand, the model is about whatever your data item is, users or movies or whatever, but on the other hand, the classes know how to load, save, and delete themselves. They know how to talk to the database. They have these other behaviors that let them be associated with other models. So isn't this really having multiple responsibilities in a single class? Because technically, you get all of this just by inheriting from Active Record Base. So is Active Record Base in violation of SRP? But in fact, if you look at the source code for Active Record Base, which I encourage you to do, most Active Record behaviors are actually included as modules. So all of the association stuff is a module that's mixed in. The idea that you can talk to the database and maintain a connection, that's a module that's mixed in. It's connection adapters. Validations, we already saw that that's a module because in the Oracle of Bacon homework, you use that module independently of using the rest of Active Record. So really, when you write your model-specific business logic, even though you're inheriting from Active Record Base, which does all these things, each one of those things is its own module that's getting mixed in. And the Active Record Base class actually doesn't do that much stuff. So it's a way in which behaviors can be deceiving, because when you look at it, you're inheriting from this uber class that gives you all these magical behaviors, right? In fact, each set of behaviors is actually well contained in its own set of modules. In any case, if you find that you do have this problem, what can you do? For example, here's a hypothetical where we've got a moviegoer, and part of the fields in a moviegoer are things related to the address. And we start accreting methods that really are just about manipulating the address, right? So we're heading towards a situation where there's a collection of attributes and a collection of behaviors that sort of are disconnected from anything else that our class does. And we might think, OK, let's remove that responsibility from the moviegoer class. Where might we put it? One possibility is that you can put it in its own class, and you can actually set it up as an association. So either way, in the class diagram, we're going to say moviegoer now just has these whatever attributes were left behind, but we're going to pull out address as a separate class. Now, we still have to figure out how we're going to store that, right? We've got to store that information. And depending on your point of view, you could either have a separate table for it, so it would be its own active record model around addresses, or you could actually find a way to store it in the same table, but still in your application have them be separate. So let's talk about that. The way you'd have, if you were just doing a separate table, this would be easy, right? You know how to do this. You set up a new model for address. You establish a has-one relationship from moviegoers to addresses, and you're done. But suppose you thought, you know, it's gratuitous to have a whole separate database table. I would like address to be a separate class, but I still want to be able to just store it along with the moviegoer info in the same table. So here's how you could do that. So here's another way to do it. Here's my moviegoer, my customer class. This is a regular old model. It has its own table. But I'm going to say that this is kind of like a quasi-accessor. It's composed of this other class called customer address. And in the customer address class, I'm going to have attributes street, city, and zip. I'm going to map those to database columns in my own table for address street, address city, and address zip. This is completely declarative, right? So what will happen here is whenever you create a new customer, one of its components will be a customer address. And whenever you save it, the customer address component will be serialized and stored in these fields according to the mapping that you set up. So now in your application, customer address is still a completely distinct class, right? It has its own methods. You can operate on them. You can write separate tests for it. All of the great things that you can do by having a class that's well encapsulated. But you don't have to decide to have it in its own table just to take advantage of that. So that's what composed of buys you. Okay, so that's one way to solve the problem using either has one or composed of. You can also use composition and delegation. So what do we mean by that? Because this is something that comes up all the time. Composition and delegation means I'll still have a customer. This is kind of my main class. And I'll still have a helper class that I've pulled out the address into. But in some cases, it would be convenient for the address class to not have to essentially duplicate methods that otherwise would have gone into the customer class. Let's show a code example so you can see what's going on here. So again, here's my customer class. And part of what I would do in my constructor, this is the component part, right? Remember we talked about one class can be a component of another. Well, here, I'm going to have an address attribute in my customer class, and its value is going to be an instance of this other class. Here's my address class. And when it gets initialized, it will get a copy of the customer to whom it belongs. And the reason we can do that is that we can now decide if there was a good reason to put some of these methods into the customer class, we can still manipulate address as a separate class, but delegate the calling of these methods back to customer. So what that means is customer actually is going to implement all these because there are logic reasons why it's easier to put them in that class. But for the purposes of coding and testing, I can actually behave as if these methods were implemented by the address class itself. It's just that when the address class, or when an object of address type gets called or gets instantiated to call one of these methods, rather than implementing the method itself, it will delegate to the customer instance that this address was initialized with. Does that make sense? So you still have the ability to keep them separate. You have the ability to think in terms of one class being a component of another, but you can just say of the methods, I'm going to behave as if the methods live along with address, but I have the option of keeping them along with customer because there's, maybe they interact with other information about the customer that actually makes it easier not to pull them out. So I delegate them back. And we're going to see this idea of delegation used over and over. Delegation is a really simple concept. It just means I'll pretend that I can do this method, but I'm really just a go-between. I'm going to hand off responsibility to somebody else. You don't need to know who it is. You can behave as if it's my method. You can test it as if it's my method. But be aware that when you actually call it, someone else may be doing the actual work. I'll try to refrain from some snide analogy of what in real life that is like. So here's a question about the single responsibility principle vis-a-vis the SOFA guidelines that we saw in connection with individual methods. So which of these is true? And again, not a trick question, so exactly one of them is true about a class that properly observes SRP. That in general, we would expect to see a correlation between a poor cohesion score, low cohesion of methods, and poor SOFA metrics, right? So that we would expect those things to track each other. That low cohesion is a possible indicator of an opportunity to extract a class. That if a class is doing a good job respecting SRP, its methods, the methods in that class, probably also respect SOFA. And conversely, if you have a class whose methods respect SOFA, the class as a whole probably respects SRP. So which is true?